Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started.
In smart building automation, the discussion around wired versus wireless systems is often driven by preferences rather than engineering analysis. In real projects, the decision is rarely technical only. It involves consultants defining standards, developers managing cost and risk, and contractors delivering a system that actually works on site. Today, I want to explain in simple engineering terms how KNX wired systems work, how Zigbee-based wireless systems work, and why the real challenge is not the protocol itself, but the system design. KNX is a distributed wired control system. Each device, sensors, actuators, keypads communicates over a dedicated bus line. There is no central controller required for basic operation. Intelligence is distributed across devices. This creates deterministic communication. Messages are transmitted over a fixed physical medium. Latency is predictable. System behavior is stable and repeatable. Because it is wired, the system is immune to RF interference, independent from network overload, extremely reliable over long operating life cycle. This is why KNX is widely used in high-end residential projects, hotels, hospitals, and large commercial buildings, where predictability and long-term stability are critical. Zigbee is a low-power wireless protocol designed specifically for control and automation. Unlike Wi-Fi, Zigbee focuses optimized for small data packages, low latency, and low power consumption. Zigbee networks typically operate using a mesh topology. This means devices act as both endpoints and repeaters. Messages hop from one device to another, and the network can reroute itself if one path fails. This provides flexibility and scalability. However, performance depends heavily on node density, physical layout, and the RF environments. A well-designed mesh performs very well. A poorly planned mesh becomes unstable very quickly. Mesh networking is often misunderstood. It does not automatically guarantee reliability. Each additional hop introduces latency, dependency on device health, sensitivity to environmental changes. So the engineer's role is not just selecting a protocol, it is depending on the network topology itself. So without proper planning, no mesh network can compensate for weak engineering. From an engineering perspective, wired systems prioritize predictability, stability, and long-term reliability. Wireless systems prioritize for flexibility, speed of deployment, and adaptability to existing buildings. The real mistake is choosing a technology without understanding project requirements. This is why early alignment between consultant, developer, and contractor is critical before looking for any technology choice. In many modern smart buildings, the optimal solution is hybrid. Critical and time-sensitive functions remain wired. User-facing or changeable functions can be wireless. This approach balances reliability, flexibility, execution risk, and cost. Finally, KNX and Zigbee are not competitors at all. They are tools. The real expertise lies in knowing when, where, and how to use each one. Smart buildings succeed when engineering decisions come before technology labels.
If you found this helpful, like, share, and subscribe for more instrumentation tutorials. Thank you so much for watching and have a nice day.